Okay, so we're going to do classifying figures by coordinates. This is question number one. They give us four coordinates. They tell us angle A is a right angle, and they want to know, is this a rectangle or not? So I went ahead and I went over to Desmos and I plotted all this out. And I've done that on other things. I didn't do it here just for the sake of time on the video. I didn't make it super long. So I went ahead and I plotted it, and now I've copied it. Now, they've told me this is already a right angle. Now, if you look at the question, there are two reasons you're going to get a yes. Either the opposite sides, A, B, and B, C, A, B, and B, that doesn't even make sense. Okay, actually, if they're all equal, that's a square. So if you could show all sides are equal and you have a right triangle, then you have a right angle, then it would be a rectangle because a square is a rectangle. So that would work. The other thing is they don't look at the lengths, they look at the opposite sides being parallel. Now, we can clearly tell here the sides are not the same length. So that must not be the one we're going to do. So what we want to see is, are the sides parallel? If the sides are parallel, then we have uh you know, right angles, because you're going to, and we'll talk about that here in just a second as we do it. Okay, so here we go. We're going to talk about, is this a rectangle? And you can do it by lengths. You can do that, but really because a rectangle has right angles, it's much more beneficial to talk about the right angle. So this, again, the slope of this line right here is I went from 6 to 5. So I went down 1 and I went over 3. So the slope of that line is negative 1/3. This one also went down 1 over 3. The slope of this line is also negative 1/3. So those are definitely parallel. Now here, I went from 5 to negative 4. 5, I went down, or you can, if you're going this way, if you want to go from C to B, it doesn't matter. Your choice. I mean, if you prefer to go this way, I start at negative 4, I end at 5. I went up 9. And then I went from 0 to 3. So that slope is 3 over 1 when reduced. Those are opposite reciprocals, which we just talked about on the first video I did. That clearly makes this a right angle, and it makes this a right angle. And since they told us this was a right angle, this also has to be a right angle. This is indeed a rectangle. Now, again, we'll just confirm from negative 3 to 6 is a change of 9. From negative 3 to 0 is a change of 3. That's the same slope. That's also a slope of 3 over 1. So the sides are both parallel, which makes it a parallelogram. And because the slopes are opposite reciprocals, that makes the angles a right angle. So indeed, it is a rectangle. All right, next question. So we want to know if what kind of triangle we have here. So again, I'm going to go over to Desmos and plot it out. Now, this can be a bit time consuming if those of you who've seen me do this before. Drawing out a picture on Desmos to get it to draw the way that I do takes a little bit of effort and time. You have to first type in each point, and you got to do it a couple times so that you can get them labeled the way you want. So I have the point 1, 9, and then I got to do it again. And the reason I do that is because one of them can be labeled the point and one of them can be labeled the letter. And usually I'm try to make them the same color. You don't have to do that, but that's just something I do. So 1, 9 is there. Then we're going to do 11, negative 7. So again, 11, negative 7, that's 0.1. We're going to label that. Then we're going to do it again. 11, negative 7. We're going to label that. That's our point B. And again, I'm going to make them all black. You can make them whatever color you like. And then the last one is the point negative 9, 3. So negative 9, 3. And again, we have to do it twice. And again, we want to label them both. And then this is the point C. And we're going to turn them both black. And then if I want to draw in the sides of the triangle, I actually have to do that by putting in a chart, a table, and then you have to put in each one of the points. So 1, tab 9, tab 11, and then negative 7. Oops. and then negative 9, 3, and then you have to put in the point you started back with so it draws in the entire figure. And then you tell it, hey, let's go make these solid lines. Well, it didn't work. Let's go make these solid lines. Okay, so there's my triangle right there. And we're going to copy it so we can draw on it. Just like that. So there's my triangle. Now I'm going to go in here and it's going to say, is this a right triangle and why? Now, I just said a few minutes ago, very rarely do I ever want to say, what does it look like? And so what we're going to do is we're going to find the slopes of all three sides. Now, if you ask me visually, if there is a right angle, it's going to be here, but we're going to check. We're going to make sure. So the slope of this side, I start at 9. I start at 3. I end at 9. That's a change of 6. Oops, let's go over here. That's a change of 6. Okay, I start at negative 9. I end at 1. That's a change of 10. So that is a slope of 3/5. This one, I start at 9. I end at negative 7. I went down negative 16. 9 to negative 7 is down 16. From 1 to 11 is 10. That reduces to negative 8/5. And then here, I'm at 3. I go down to 7. That's down 10. And I'm at negative 9 and into 11. That's 20. So that slope is negative 1/2. Now, are any of the slopes opposite reciprocals? The answer to that question is no. Now, I'm going to double check my numbers because I thought that was going to come out to be a right angle. So 3 to 9 is definitely 6. Negative 9 to 1 is definitely 10. That's 3/5. 9 to negative 7 is definitely negative 16. That's down 9. That's correct. And 1 to 11 is definitely 10. So this is not, it's not a right angle, it's not a right triangle. None of my slopes are opposite reciprocals. So it doesn't have a pair of perpendicular sides. All right, next one. All right, here we go back to Desmos again. So we're going to go back to Desmos, and we got some graphing to do. So first, let's delete out all this stuff. And again, it's just going to take us a minute or two to get this graph. So I've got the point negative 1, negative 9. That's A. Pardon me, negative 1, positive 9. And I need to label those both. That's point A. And let's make them both black. 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 Now we have the point 9, 4. And label them both. Turn that one black. And make that point B. And then we have the point 4, negative 6. And another 4, negative 6. Again, label them both. Make that one C. Turn them black. And lastly, we have the point negative 6, negative 1. And again, label them both. Call that point D. Now, by going and accurately graphing them, it does at least give me a fairly clear picture of what's going on here. You know, I would tell you, do not ever make decisions based on what you think it looks like, and that's absolutely true. But with a little, I mean, at least by graphing it accurately, as we are. I think that that gives us a little more benefit of the doubt in that. At least that we can probably have a better visual image right off the bat of what we've got. I don't know what this question's going to be, but I can tell you just from looking at it, it definitely looks like it might be a square. Um, we'll absolutely make sure that it's a square, but it definitely looks like it could be a square. So let's go back and see what they want to know. Yep, they want to know, is it a square? Um, you know, square, we got a couple different things. We got to prove that the sides are equal, and we have to show the slopes, and we're just going to do that because if it's a square, the changes we'll show them. They're all going to be the same. Okay, so from 9 to 4 is down 5, and from -1 to 9 is a positive 10. Now that's going to reduce to -1/2, but that's actually, I really want to remember this original change amount here. This is important in knowing whether it's a square because it has to do with the distance. Now here, we're going from -6 to 4, so that's a change of positive 10. And we're going from 4 to 9, that's a change of 5. Now that's really important, okay? This does reduce to positive 2 over 1. So we have absolutely proven this is a right angle. But what is super important here is notice how the changes, while the x was the y and the y was the x, they're the same amount. So if I used Pythagorean's theorem, a and b would give me the same total. So a squared plus b squared and a squared plus b squared is still going to give me the same total. So these two are indeed also the same length. So I'm really heading towards this is probably a square. Now, this side, from -1 to -6 is a change of down 5. And from +6 to from -6 to +4 is a change of 10. We're at the exact same again now. These are exactly the same changes, right? So these are also the same length and they're parallel, and you get another right angle. And I don't really even need the last side. Everything I have makes this have to be a square, but we'll do it just to show you. -1 to 9 is a change of 10. -6 to -1 is a change of 5, which again reduces to 2 over 1. But again, notice how the changes were the same. So we have all four sides are equal and all four angles are a right angle. This is indeed a square. And, you know, AB, let's see which ones. AB is parallel to CD, and BC is parallel to AD. Okay, that's true. Yes, because A, B, B, C, C, D, and A, D are all equal. Yeah, I actually think we could pick either one of these. Um, we definitely showed they're all the same. So I'm just going to pick A. Okay, see, what they're saying is we wouldn't have picked this one because them being parallel isn't enough. And they're right there. It has to be the same length too. So can't just be parallel. It needs to be parallel and the same length. Makes perfect sense. All right, last one. We're doing the same thing. Is this a rectangle? Now, again, we can go and draw it out if you'd like, but you don't have to. I'm going to show you what to do if you don't want to draw it out. You can just talk about this slope right here. You don't have to go draw a picture. What is my slope between A and B? So again, let's copy it so I can. If you don't want to go to Desmos and you don't want to spend the time drawing this out and taking the time to do that, you don't have to. What you can do is you can say, okay, what is the slope of AB? What is that slope? So the slope of AB is from -2 to 4 is a change of 6. And from -6 to -4 is a change of 2. And so that reduces to 3 over 1. And then you can say, okay, what is the slope of BC. All right, so from 4 to 1 is a change of 3. From -4 to 8 is a change of 12. And that reduces to 1/4, not 1/3. And when I did make a mistake, it's negative. That's negative. -1. So 4 to 1 is down 3. -4 to 8 is up 12. And they are not opposite reciprocals. That's not a right angle. So while angle A is a right angle B is not a right angle. You don't need to do any more than that. It clearly is not a rectangle. Now, why? I'm going to see, okay, this one doesn't make any sense, again, because that would be for a square. We know it's not yes. So it's either no because they're not parallel, or no because one is shorter than the other. We just did slope. I know they're not going to turn out to be parallel because they didn't turn out to be perpendicular. So it's going to be C. All right. Again, that one's a little more complicated. If you have any questions, don't hesitate to ask.